Hello guys, I'm back with another video. Today we're going to do a question on trees. So this is my first video on trees. So let's first understand how the traversals are done using recursion and even the iterative method of traversal. I'll explain both of them. So I hope you people understand it. So we'll directly jump into a question and I'll try explaining it to this question itself. It's the binary tree level order traversal. Let's not care about that for now. Then I'll explain about the three types of traversal. The three types of traversals which are there are pre-order, there is in order, and there is post order. So here you can use let's try using a function. Let's try creating a function to do this traversal. So I'll just do it for printing. So let's do pre-order. So and in pre-order, so if at all the root is this is the basic condition for any recursion which is used in the tree concept. So if the tree is null, then obviously we would return. There's nothing to do with that. And first in pre-order, see there's an order in this. There's like a specific sequence which should be followed. In pre-order, it's going to be the root value, and then it's going to be let's put arrow here, and then it's going to be our root, and then it's going to be left, and then it's going to be right. So that's how it's done. And in order, in the case of in order, it's like it's going to be right, and then it's going to be the root value, and then it's going to be the left value. And then poster obviously you can guess it. It's going to be the right first, and then left, and then it's going to be the root itself. So these are the three traversals which you have. First, let's write for pre-order. In pre-order, the root value is first. So let me print the root value. Here it's given. Here you can see the class's structure is like this. It's the value, and then left and right there's a constructor here. In the constructor, you can pass in the value, and you can create new nodes. We'll check. We'll think about it later. But now our main problem is we have to print the pre-order of the tree. So the root dot val, and then next it's going to be a recursion call to the root dot right, to the root dot left, and then it's going to be pre-order to our root dot right. So let us try and call our function here. First, here you can see it needs a list as its input. Let's give the function what it wants. So let's put as temp. And let's return the empty value, no problem. So pre-order. So here this tree you see here, we are giving a pre-order we are giving a pre-order for this. We're printing the pre-order of this tree 3, 9, 20, 15 and 7. So if it is pre-order, first we would have the root. So 3 would get printed first. In that sequence, we would go to the last node till the leaf node comes. So let us run the code and check once. Yeah, see, you see it's 3. I'll put a space in between so that you guys can understand it better. Yeah, so yeah. So you can see it's 3, 9, 20, 3, 9, 20, and then 15 and 7. So this is going to be the pre-order sequence. Let's do the same for in order. Same arguments are passed, and then here we will have the in order we'll have the root. We'll have the right first and then root. As you can see, only the sequence of the recursion calls are changing here. Oh, sorry, then wrong name. Yeah, you can see 9, 3, 9, 3, and then 15, and then it's 20 and 7. So you can see the sequence here. Let me zoom in. You guys can check the sequence here. It's 9, 3, 15, and 27 and 7. Let me do the next one. The next one is pretty obvious, the same way you would do for the post order also. I would just change the, let me close this console. Okay, post order, post order. And here the value is going to come in the end. That's it. So let's run. You can see it's 9, 15, 7, 20, and then 3. So it's all coming from the end and it's going to the beginning. So this is the post order sequence. So these are all fine. These are pretty easy. So we will come to the main agenda today. Today we are going to do the level order traversal using both recursive and the iterative way. So I'll first we'll try the iterative way. So I'll explain how to do it. So imagine you see this tree right here. So each tree has its own level. So each tree has its own level and height. So first we are going to use the height of the tree. Each node's height we would use it, and then we would follow the level order traversal. So right now in this third height, like nodes with third height, there's a tree here, and then with 2 there's 9 and 20, and with the height 1 there's 15 and 7. So for level order, or you would even call it a breadth first search, and a normal traversal is called as a depth first search. So here it's nothing but a breadth first search. So you're going level by level. So first level is done here, first level, second level is done here, and then you have your third level here. So imagine, I'll zoom out and explain. So you can see there's a number. Initially there's a 3 here, so you would initially have a queue with number 3 in it, and then afterwards you would pop out the 3 and then you would print its left child and right child. So 9 and 20 are coming here, and then afterwards 9 doesn't have any children, so you would just pop it out, and then 20 would 20's children, you would put your 20's children into the queue. So 20 has children such as 15 and 7, so you would put them into your this thing, and then each order by order you would add it to your array list. So you can see here it wants a list of lists which are of integer values. So you would create each time you add, or each time you update the queue, you would add those elements to your inner list, and then you would print out the answer. So I'll code it up, then we can see properly what to do. So let me zoom in into the editor. Theme is boring, I'll change the theme. No, no, no. Yeah, this is my favorite. Okay, now let's try. Let me zoom in more. I'll remove these, we don't need this. So let's now focus, our whole focus should be there on this. So let me remove this option also. So initially you can see there's a linked list, and then we would need a queue also. So our queue which is there, so our queue would take an integer value into it. Our queue would take an integer value it, and it's going to be queue equals to, it's belonging to the class of array list. So we created an array list, and then if at all the root is equal to null, we will return a null. We will return the array list as it is, and then next step would be we would add our if at all the root is not null, then we would add it to our main queue. So queue dot add the root value to it. No problem. Sorry, it's not an integer; it's a 3 node because we are storing the nodes one by one. So now our So now our iteration will start. We would make sure that our we would do this till our queue is not empty. Q dot is empty is the function. Till it's not empty, we would go on with our iteration. Sorry. So now we would first have a present value. So we are going to use the queue's poll function. So what does a poll do? It removes the head of the queue and then it returns the value which is being popped out. So first we would have the size of the queue. So we'd use the queue dot size, and then our next step would be we would create a list, so that in a list, so that we can add this to our main answer list. And then we would iterate from till the length of, we iterate to the queue now. So I equals to 0 and then I is less than the length, and then we will go on till there. Now we would use the poll function here. So present value this is, so present value is going to be q dot poll. So one element is going to get popped out and then it's going to get added to our tree node, the variable called present, in which is of the type tree node. So if at all the present dot left it's not equal to null, if it's not equal to null, then we would add it to our queue. Q dot we would add it to our queue. Q dot add present dot left. Similarly to the right also. So let me copy this. So right, and then after adding all this, we would add the present value to our inner list. Inner dot add what should we add here? So inner dot add the present node, present dot val, because we are only taking the value. We don't care about the other factors such as the pointer of it or the left and right indexes, left and right pointers of the given node. So then after adding all this, our inner value which is there, we'll add it to our main answer list. So temp dot add inner value would be added here, and then we would just return the temp, which is the main answer. Let's run it. So Q is not supposed to be a array list. Q is supposed to be a linked list, I guess. Yeah, we got our answer. Let's submit. I already submitted twice. Yeah. You guys can note this down that it's 43% faster, and then it uses less than 42% space. But if at all let's try the recursive solution now. Let me clear this up so that you guys can understand the recursive solution. So our recursive solution, it needs three main functions. One is the height. So that first we'll write a function to find the height of the linked list. So I mean, to find the height of the tree. So first the first thing which we would do is so first let's create a answer node, answer list. That's the first thing which we do. And then after adding this, our next step would be, we have created a list here. Our next step would be, first we have to create a function called height. So I'll tell you how to find the height of a given node. So imagine you have a node here 3. So what would its height be? So height is nothing but the maximum distance from its leaf nodes from the till the end point. It's the maximum distance. So for example, you see a 7 here. Let me zoom in. You guys can understand better. So you see a 7 here. So distance 7 is the ending and 15 both are in the same level. So distance between them is 3. So this is the height of the node 3. So 9 you see it's going to be 1 because it doesn't have any children. And then of 20 it's going to be a 2 because it's in the second level, or the distance from the this thing is like 2 units. You can consider it that way. So we would use that we would use a recursion concept to find the tree. So our height function would return the height of the given node. So again, same base case again. If root is equal to null, obviously we would return a 0. And one more thing is we would have a the left height. And left height is going to be height from the, and then right is going to be height of the right trees. Recursive leap of faith here, you would just make sure that your right trees return your value of the height. You don't care about it. Like normally, you shouldn't care about it. You just think it gives you the answer by itself. And this thing would return the max of left and right plus 1. So let's test our function out in our this thing, in our main method. So return the answer, no problem in that. So height of imagine let's see the tree once more. So height of 3 is how much? So 3, the node 3, which is the main parent. So what is the height of that? So we'll find it out right now. So let's output it. Let's check what happens. So you see a 3 here. So this is the height of this node. Imagine I find the height of this 20. So it's going to be root dot right. I would just pass it. So what is the height of this? It should come 2. You see there's a 2 here. So our function is working properly. Even in the edge case it works. For example, I give a 9 there. It would obviously give me a 1. So no problem in that. So next step would be we would need a function which would print. We would add. I'll tell you the structure. Wait a minute. So this is our outer list, right? So inside this we are going to add a list. This is going to be a list of lists. So for each list we need to add separate values. So for that, let me do one thing. Let us create one inner list. So imagine this inner value is there. So let's write a function here. So what is this going to do? It's not going to return anything. And then level by level, I would print the answer. So then what are the arguments? The root and height. And then what else we need? We need the inner list. So our first, or obviously our base case is going to be if the root is equal to null, we would return a 0. That's anyway there. I meant we would what we do? We would just return the. Oh, we don't do it. We just return. We don't return anything. Obviously, our function is void, so we don't return anything. And if at all the height is equal to 1, what would we do in that situation? We would just add it to an inner list. Inner dot add. What do we add? We would just add the root value. Root dot val here. No problem in that. And if the height is greater than 1, then we need to do 2 recursive calls on this function. So it's going to be the root dot, yeah, height minus 1, and then the inner function going on as it is. Let me close the console. Let me zoom in. Yeah. So now you see there's a inner. So if it's null, we would return nothing, and if it's inner, we would just add it to our main inner list here. So let's test it out once. Let me output the list value. Yeah, our root is going to go. Just imagine this. The height of 3 is how much it's going to be. It's going to be at level 1, and this is level 2, and then this is level 3. I'll put a 3 here, and then I'll put the inner value here. So let's see what we get as our output. So let me run the code. You can see 15 and 7 are there. This is for the level 3. So 15 and 7 is here. Imagine I give a 2, you should get 9 and 20. See 15 and here, 15 and 17, 15 and 17 are right here. So this is what is happening. I'll print for level 2. Yeah, so we got a 9 and 20. I'll print for level 1. You can see level by level. So it's going to be 3 and then 9, 20 and then 15 and 17. That's what we wanted as our answer. So let's write another function so that it'll add it to our main list. So we'll have a for loop in that. I'll name it as last because this is the last function which you're using in this code. So what all we need? We need we need the answer list. I'll copy paste this. Take this from here. Yeah, that's it. We need these. And again, so this is not going to be a recursive function. It's going to be a normal function. So the height is going to be of the root. So what is the height? We have to find it out first. So I'll name it as ht because otherwise there'll be a lot of ambiguity. So ht of the height of the root value. So we'll have the iteration go from to the ht value. It go till there, and I'll create one temporary list here. So we don't need this here. So one inner list will be there. So then our next thing which we will do is the level of so we would call the level function here, and then height is going to be I value, and then we're going to have what else? The inner value is going to be here. The inner is going to get filled here, and then after the whole iteration thing, we would just add it to our inner after every iteration. Yeah, fine. So let's do our function call now properly. So what is the last function taking? Our last is going to take the root, and then it's going to take the answer itself. So we'll just return that. Let's see what happens here. We're getting a wrong answer. Even the null value is coming. I don't know why. So ht equals height of root. So we're going to start from 1 because here we wouldn't pass I equals to 0. Because if it's a 0, there's no node at the 0th level. So let's run now. I did a mistake here. The iteration starts from 1. Yeah, it got accepted. Let's submit and check once. Yeah, you see, we got it. But the space is optimized, but the time is kind of messed up here. It's not so time optimized solution. So yeah, I hope you people understood it. These were the three. These were different iteration, different traversal methods in trees. So our next video would be on this. The hacker rank question is going to. We have to find the top view of a tree. That's it. Fine. Thanks a lot.